So in this video, we're gonna use the ratio test to prove that this series, or to check if the series converges or not. Um, how do I know I'm gonna use the ratio test? Whenever we use the ratio test, we want things to cancel if the next term compared to the previous term. I'm gonna write down if you remember what the ratio test is. You take the limit when n goes to infinity of the an plus 1 term divided by the an term, and you call that L, and if that L is less than 1, then the series converges, and if L is more than 1, it diverges. So right here, it becomes it converges or it diverges. If it's equal to 1, we wouldn't know. There's another video where there's an example with this. So what I'm going to do is directly find that limit. Okay. Oh, sorry. And so this, I normally use the ratio test because whenever I have factorials, a lot of things cancel with the next term and the previous term. Because the key point to remember is that you can write n factorial or n plus 1 factorial, to write in a consistent way, is n plus 1 times n factorial, right? So just using that, you see that many things are going to cancel. So in this problem, the only thing I have to be worried about or be careful about is to write these factorials carefully. So I'm going to take the limit. I'm going to use the ratio test. Using the ratio test. So I'm going to use this problem in a homework or a quiz or an exam. You need to write carefully. I'm using this test. Okay, for whoever's grading makes sense to know what you're doing. So you find the limit when n goes to infinity of the n plus 1 term. And the only thing I have to be careful is that it's not this. This is not the n plus 1 term, right? It's not this. So the bottom doesn't even make sense. You have to put a parenthesis around it, right? And after that, it's squared. And the top is wrong because it's not 2n plus 1 factorial. It's 2 times n plus 1 factorial. Right? So you're replacing this n in the term for n plus 1. So that n is multiplied by 2, and in this case, n plus 1 is multiplied by 2. Okay? In the denominator, this n factorial is replaced by this n plus 1 factorial, and then it's squared, right? If I wanted to do this problem, I think it's interesting just to write how do you manipulate these factorials and the squares and the parentheses. So be careful how to write this. Okay, now this is the n plus 1 term, and I'm going to be dividing by the n term, right? Should be divided by the n term. So I'm going to just copy this by n factorial squared. But in one step, after you did this a few times, you realize that you can write it in one step, which what you really are doing is writing the n plus 1 term, which I'm going to write this, I'm going to write it like 2n plus 2 now, factorial, divided by n plus 1, nothing I can do here. Well, I can write n plus 1 factorial is really n plus 1 factorial times n plus 1 factorial, right? I'm going to write it like that. And then this denominator down here, this part, I'm going to multiply by the reciprocal of that, right, to put it under the same denominator, under one fraction, sorry. So now the n factorial goes on the top, this n factorial. But that n factorial, I'm going to write like n factorial times n factorial, just that makes things a little bit more clear. And the denominator, I'm going to write what was this numerator here, which is the 2n factorial. Okay, now I can see what's going on, and let's do some algebra here. So I'm still taking the limit. And now each one of these terms that I had here, this n plus 1 factorial with that n factorial, I'm going to use exactly what I did here, right? This n plus 1 factorial is this, so it cancels. That n factorial term is going to cancel everything from this guy except an n plus 1. And the same for this guy. This guy has n plus 1 factorial. This term is going to cancel everything except the n plus 1. Correct. Now, in the top, I'm going to write a little bit more. The 2n plus 2 factorial, this term, let me change if you want. This term here, this term that's green now, let's make it, it really is 2n plus 2 times 2n plus 1 times 2n, and keep going until I can write 2n factorial, correct? So the 2n plus 2 factorial, you can multiply every number between 2n plus 2 and 1. The first term is 2n plus 2. The second term is 2n plus 1. The next term is 2n. So you have this 2n factorial now. So I took care of that, and now this term is still in the bottom. Sorry, I need to write it like this, of course, if I know parentheses, that's wrong. It's not 2 times n factorial, it's the number 2n factorial, correct? That's what I have here. This guy is a 2n factorial in the bottom. Okay, and now we see what things, now we can see what is canceled here. So this becomes the limit when n goes to infinity. The top, now these terms cancel as well. So you only have these multiplied. To do some algebra, this becomes 4n squared. You're going to have a 2n and a 4n. So I think you're going to get a 6n, n plus 2. And in the bottom you have n plus 1 times n plus 1. So it's n squared plus 2n plus 1. There you go. So this is the limit we need to get. I get the limit. If you know how to do this one, we should know by now that what you do to manipulate this limit is you divide by the biggest power. Most of the time we don't write these steps anymore, but this is what you do. And you do, it becomes really this. Many of you know that this becomes a 4, right? It's going to be a 4 plus 6 over n plus 2 over n squared. In the bottom I get a 1 plus 2 over n plus 1 over n squared. And in the limit when n goes to infinity, all these terms are 0, so just a 4. So, since the limit we got is a number 4, which is more than 1, using the, we're in this case, so the series diverges. So there we go. So the series diverges. Okay, so this is a nice example to use the ratio test and its power, and you have to be careful with the algebra that works out, and we'll get it.